Step 2, Statistics, 2007, question 14. It's question 2 from the Step 2 Stats Support module. So, okay, we have a function with continuous probability density. The fact that it's continuous is going to be important because it tells us to sketch it. Now, of course, okay, so we get out the sketch. Between 0 and 1, it's just 0, so it's just a flat line. Between 1 and k, it's log of x. Now, I've got a log of x, kind of, if you do the entire graph, looks like this. So I just need to draw that between 1 and k, so it looks a bit like this. It's kind of caving like that a little bit, so it's concave like that. And then log of k is just a constant, so between k and 2k, it's just a constant. I know that this isn't a perfect sketch of a axis here, but it's fine. And then between 2k and 4k, now it's probably worth mentioning that at k, this graph is log of k there, but also log of k here. So that means it's continuous, right? Because there's no jump. It just goes from here smoothly to the next bit. And now a minus bx, now that means that if this is still continuous, and if when x is bigger than 4k, it's going to be 0, that means this, obviously this is just a line with negative gradient. It goes from here down to there if it's continuous, and then continues going along like 0 from there. So what this implies, of course, is that when you put in 4k into here to get a minus 4kb, that's equal to 0 because the graph must join up here. And likewise up there, when you put in 2k into this to get a minus 2bk, that must be the same as log k because of the continuity. So, okay, that's kind of interesting. And now it says determine a and b in terms of k. Well, I think we can just look at this to do that, right? So if I just rearrange this a little bit and then maybe just double this entire equation, I can put the 4bk into there to just make it an a. If I've just doubled this and then replace it with a. So I get a as this, and then of course I can just put the a's into there maybe and rearrange for b. I think that's what I did. You can also say that b is just this because b is the gradient of this line. So it's clearly just log k over 2k. So that would also work. It's also positive, I guess, because the negative is built into it as well. And then it says find the numerical values of k, a, and b. So how are you supposed to do that? How are you supposed to find the numerical values? Well, we know that this is a probability density function, so the area underneath the function must be equal to 1. So therefore, if we integrate between 1 and k, log of x, and then we add that to this area, which I'm not going to integrate because it's just a rectangle, and then we add it to this area, which I'm not going to integrate because it's just a triangle, if I add those three areas together, I should get to 1. So that's exactly what I've done here. Integrate between 1 and k of log k, because that's this function here. This is just a rectangle width k height log k, so that's just that. And this is a triangle width 2k height log k, so that's width times height times a half because it's a triangle. Of course, this just makes k log k plus another k log k makes 2k log k. And then the integral of log of x. Now, I would recommend that you just go into a step exam knowing the integral of log x is x log x minus x. If you don't, just times it by 1 and then do integration by parts, but it's just x log x minus x. If you want to see the proof of that, I'm sure there are good videos on YouTube that will take you through the integration of log, but I'm just going to say it's this. Then we're going to put in the k and the 1 in. Log of 1 is 0, so this just makes a minus minus to make a plus 1, which will cancel with that one, and we'll end up here. If we divide everything by k, because k can't be 0, because then this statement wouldn't make any sense here. So that k can't be 0, so let's just divide by k. And then, of course, when we rearrange this, we're going to get k as e to the power of third. So that's the numerical value of k. And, of course, I can put that into here to find the value of a. So log of e to the third is just a third. So, therefore, a is 2/3. And here, log of e to the third is just a third. Divided by 2 lots of e to the third is 1/6 e to the third. And the e to the third is on the bottom as well. Yeah. And we get a and b there. So that's going to be that. And then it says find the median value of x. I've redrawn this graph to just have all of the relevant values in that we found, so that's fine. Find the median value. Now, the median value is, of course, the point in which there is half the data beneath and half the data above. So what that means for the graph is there is some line that I can put through here, which I'll call the median, this value here, the median, whereby half of the area, which is a half because the total area is 1, half of the area is here, so half, and half of it is there. Now, how do I know the median is here in this rectangle? Well, I don't. I'm going to sort of prove that as I go along. It could be over here somewhere, or it could be over here somewhere. I'm going to show that it's definitely in the middle like this in a second. But let's first say, okay, well, what's the integral between 1 and e to the third of log x? Let's just find the area that's part of this bit first. So I'll do that. Log of x still integrates to x log x minus x. It always has. Then we put in these two figures here, and we get this. I'm doing this very quickly because I think it's quite boring, and we'll end up with this. And now, so that's the area. That's this total area here. Now, what I'm going to do is I'm going to do a half take away that, because that will find me this area here, because I'm pretending this line is in the correct place, such that there's half behind it. So if I just do half take away this, I'll get this rectangle here. And what I want to just verify quickly is that indeed bigger than 1? Because if it's not, then that means that m was in the wrong place, right? If this is, do I mean bigger than 1 or do I mean bigger than 0? I mean bigger than 0, sorry. I mean bigger than 0. If this is a negative number, then m should have been put over here somewhere. Because when you do this, take away a half, this isn't even a half, right? So when you do this, take away half, you end up with a negative. Or half take away that, sorry. It doesn't really matter. So I want to verify that this is bigger than 0. But of course it is, because e to the third is bigger than 1, because 1 times 1 times 1 is 1, and it needs to get to 2.7 roughly. So this is definitely bigger than 1. 2/3 take away a half is bigger than 0. So this is definitely bigger than 0. So therefore, a half take away this area is definitely a non-negative number, and therefore there's definitely area here for me to consider. So m is definitely beyond this point here. It's definitely over here somewhere. Now, how do I know it's not all the way over here? Well, I don't yet. Again, I'm going to deal with that in a little bit later. Right now, what I'm going to say is I'm going to take this area here, and I want m take away e to the third times by 1/3, so just base times height. I want that to equal this. So this is just the height times the width of this little rectangle, and I want that to equal this value. Now, that's not hard to sort out. Just times everything by 3 and then rearrange, and you end up with this. And now what I want to verify is, okay, well, that could be the answer, unless m is bigger than this value here. If m has to be all the way over here to make that work, then that can't be right, because you're then drawing a rectangle that's bigger than it actually can exist for. So I need to verify that this right now is less than 2 e to the third, and I can just do that by just looking at it, right? If I add 3 over 2 to both sides and take away that, we get this. And now e to the 1/3, if I just do 1.5 times 1.5 times 1.5, I get something that's way bigger than e. So therefore, the cube root of e is definitely less than 1.5. Whatever it is, it's somewhere between 1 and 1.5, because 1.5 cubes to something significantly bigger than e. So therefore, even roughly e. So therefore, this is definitely fine, and m is definitely to the left of this. It's in this rectangle. And of course, this, because I've got the answer ready, is definitely the correct answer, and I'll see you next time.